In the last video, we talked about solving quadratic equations using the factoring method and also solving by extracting the root. Completing the square is another method that we can use, and it's actually a method that we can use all the time. If I look at this equation here, solve x squared plus 4x plus 7 equals 0. The first method that we talked about was solving by factoring. And if you try to factor, so our x squared plus 4x plus 7, to factor, it would have to be that we could find, some number multiplied by this times this has to be x squared, so we could try x and x. Also, last times last has to multiply to this positive 7, and the only factors of 7 are 7 and 1. And so my only option with signs and all, that's a 1, would be a 7 and a 1 here. But the idea is that it has to be that these two binomials multiply to this. So yes, the x times the x will give us the x squared, and the positive 7 times the positive 1 will give us a positive 7. But if I check inner and outer, 7 times x is 7x, x times 1 is just x, and that sum is 8x. Switching, putting the 1 here and the 7 here isn't going to change anything about my inner and outer since my lead coefficients are 1. So it's not factorable. Okay, so the only time you can solve a quadratic equation by factoring is if you're working with an expression that is factorable. So can I solve by factoring? No, we can't. The second method we talked about was solve by extracting the root. And last time we said, well, we can solve by extracting the root if we can get our equation to be written in the form of something squared equals a number. And so if we try to get our x squared term isolated, we're still going to be dealing with this middle term, this 4x. As it stands right now, just by using simple manipulations to isolate the x squared, this isn't going to be an option. So can we solve by extracting the root? Well, not really, not right now. But that's what we're talking about today. Completing the square is a method. It's really not a new method of solving. It's really just a manipulation that we do so that we can solve by extracting the root. So this method of completing the square, we learn how to do it so that we can actually then go ahead and solve by extracting the root. Because when we complete the square, then we can get our equation into the form of something squared equals a number. And once we can get it into that form, then we can just take the square root of both sides to solve. So what do we mean when we say complete the square? This trinomial, x squared minus 6x plus 9, is an example of a perfect square trinomial. The reason it is, let's look at the factorization so that we can explain that. If I want to factor x squared minus 6x minus 9, I'm going to try to find two binomials that I can multiply that will give me this x squared minus 6x plus 9. So first times first has to equal the first, so that would be x and x. Last times last has to give me positive 9, and inner plus outer has to add to negative 6. So in terms of factors of 9, I can either multiply 1 by 9 or 3 and 3. And the factors of 9 that I will need in order to get my inner and outer to add to 6, to negative 6, is the 3 and the 3. And specifically, I would want to multiply a negative 3 by a negative 3, because negative 3 times negative 3, I do get positive 9. When I multiply negative 3 by x, that's negative 3x. X times negative 3 is negative 3x. And negative 3x minus 3x does give me my middle term. When you look at the factorization, hopefully then you can see why we call this x squared minus 6x plus 9 a perfect square trinomial. Just, going off of stuff you might know, the number 25 is a perfect square. And it is a perfect square because I can find a number to multiply by itself to get it, right? There is a whole number that I can multiply by itself to get 25. So therefore 25 is a perfect square. Similarly, when we're talking about trinomials, we say that a trinomial is a perfect square if it can be written as the product of two binomials that are the same. So x minus 3 times itself gives me x squared minus 6x plus 9. In the same way that multiplying 5 by itself gives me 25. So this x squared minus 6x plus 9, that's a perfect square. And if I want, x minus 3 times x minus 3 can be more written, excuse me, can be written more simply as x minus 3 quantity squared. So, when we solve by completing the square, the idea is we are going to basically take our equation and alter it so that on one side of the equation we get a trinomial, like this, one that will factor into two binomials that are the same. Because then when we do, we can take that and rewrite it as something squared, and then we will have our equation in the form of something squared equals a number. And therefore then we can solve by extracting the root. So let's try it. So this x squared plus 4x plus 7, we were trying to solve that using methods that we had discussed previously. We decided, well, it's not factorable, so we can't solve by factoring. It's not in the form where we can just solve by extracting the root. So what we have to do is try to use a new method, another method to solve. Every quadratic equation, you can solve every quadratic equation. It's just a matter of finding the right method. So, what I'm going to do is look at this trinomial here. If I'm wanting to solve by completing the square, this is not a perfect square trinomial, okay, because it will not factor into two binomials that are the same. So what I want to do is I want to get the 7 out of my way. So I'm going to subtract 7 and then on the left to make that equal 0 and balance it with a subtraction of 7 on the other side. When I do, I end up looking, having something that looks like this. And notice I have created an empty space on both sides of the equation. What I'm trying to do is I'm going to try to find a number that I can put here so that the left-hand side factors into two binomials that are the same. But what we know is that when we're dealing with equations, if we add a value to the left, we must also add that same value to the right using the addition property of equality to maintain an equivalent equation. Okay? So I like to, when I'm doing solve by completing the square, it's my preference to think about what would the factorization look like and use that to figure out the number that completes the square. So I know that I want this to be a perfect square, or I want it to factor into two binomials that are the same. Okay, so that I can then take that and write it as a binomial squared. So this times this has to be x squared. This times this has to be this number here. And also, inner plus outer has to add to 4x. Okay? So this times this, excuse me, has to be x squared, so that would be x and x. I'm not sure what this number is, so I don't quite know what to put here and here. But if these two are the same and they have to add to 4, these both have to be 2. That's the only way that those two can be the same, and they both have to be positive 2 to add up to positive 4, right? 2 times x is 2x, x times 2 is 2x. And so, for these binomials to be the same, and inner and outer to add to 4, what I put here has to be half of this number. Okay? I like to think about the factorization first. So I know that this is going to be the factorization of this perfect square. So if this is the factorization, then it's going to have to be, so we've already decided, this number, x times x is x squared. This number times this number is this. So that number must be 4. We say 4 is the number that completes the square. It's the number that makes a perfect square on the left-hand side. And if you compare it all, so first times first is first, last times last is last, and inner plus outer does give me my middle term. And so if I add 4 on the left-hand side, then I have to balance that with an addition of 4 on the right-hand side. So I have negative 7 plus 4, or negative 3. The main purpose, and I'll go ahead and put that, of completing the square is so that we can end up with something squared equals a number. And because we have x plus 2 multiplied by itself, then we can rewrite this as x plus 2 quantity squared. So now I have my equation in a form that I know how to work with. I know that if I have something squared equals a number, I can now solve by extracting the root. Okay? Or, in other words, I can take the square root of both sides. So I have x plus 2 equals, plus or minus, 3 is not divisible by a perfect square, but I can break this into the square root of negative 1 times the square root of 3, so that would be I root 3. And last, to get x by itself, I just have to, now that I have just a linear equation that I'm working with, I have to subtract 2 from both sides of the equation to isolate my variable. So my solutions are negative 2 plus I root 3 and also negative 2 minus I root 3. So this quadratic equation actually has complex solutions. Now let's solve this as well. And I also want to solve by completing the square. All of these, we're going to go that route. Solve by completing the square. So, in this example, we already have the constant out of our way. So I am just going to rewrite this as x squared plus 12x plus something, leaving a space for the number that completes the square, equals my negative 27 plus whatever number I add to the left. Remember, if we add to the left, we have to balance it with the same addition on the right-hand side. Keeping in mind that when we complete the square, our ultimate goal is to be able to write our equation in the form of something squared equals a number. And to be able to do that, we have to create a trinomial that is a perfect square. Okay? And a perfect square, remember, factors into two binomials that are the same. So, let's figure out what those binomials are. This guy times this guy has to equal that guy, so it has to be x and x. This times this has to be this, and also our inner plus our outer has to add to that middle term 12x. Okay? So in order for us to be able to write this as something squared, these two binomials have to be the same. And for inner and outer to add to 12, these both have to be 6. So plus 6 plus 6. And so this x times x is x squared. 6x plus 6x is my 12x. And 6 times 6, that is the number that completes the square. So 36 is the number I have to add to the left to make a perfect square, and I also have to add it to the right to make a balanced equation. Simplifying, negative 27 plus 36, I end up getting 9 on the right hand side. So my condensed equation is x plus 6 quantity squared equals 9. And so now that I have something squared equals a number, I can solve by taking the square root of both sides. So take the square root, take the square root. I have x plus 6 equals plus or minus 3. Getting x by itself, I'm going to have to subtract 6 from both sides. So I have x equals negative 6 plus or minus 3. So no i's and no roots here. You can do that math. Negative 6 plus 3 gives us negative 3, and negative 6 minus 3 is negative 9. Okay? And just as an FYI, the fact that I ended up with rational solutions, no i's, no roots, I could have solved this equation by factoring, and that actually would have been a much faster process than using the method of completing the square. But as you're going through these, the factoring method only works if we're dealing with something that is factorable. Solve by extracting the root only works if we can easily get it into the form of something squared equals a number. Otherwise, we're going to have to complete the square to do it. Completing the square is actually a universal method. You can use this method to solve any quadratic equation. Sometimes it would be a poor choice, sometimes it would be a little bit difficult, or you may end up with some messy numbers, but you can use this method to solve any quadratic equation. Okay? Alright, let's try another one. X squared minus 9x minus 32 equals 0, and we want to solve. And more specifically, I want us to solve by completing the square. I can tell this is not factorable, and I can't just write it as something squared equals a number. So I am going to go ahead and try to complete the square. So I'm going to add the 32 to get that out of my way. So I've got x squared minus 9x plus something equals my 32 plus something. And again, we want this to be a perfect square. so that we can factor it into two binomials that are the same, so that we can then write it as something squared equals our number. Okay? So this guy times this guy has to equal x squared, so we'll do x and x. Last times last is going to be this number, and also inner plus outer needs to add to 9x. Okay? So again, we want these binomials to be the same so that we can write it as some binomial squared. Therefore, what we put here and here has to be half of 9 for those two numbers to add. So half of 9, that's 4.5, but just go ahead and write 9/2. And actually, it's not positive 9, but it's negative 9 that we want. So we are going to put minus 9/2 in each of these binomials. Okay? So negative 9/2 is negative 4.5. So negative 4.5 and negative 4.5 does add to negative 9. X times x does equal x squared. So therefore, the number that completes the square is the product of negative 9/2 times negative 9/2. So the negative times the negative is a positive, and when we multiply fractions, we multiply numerators together and we multiply denominators together. So the 9 by 9 is 81, and the 2 times 2 is 4. So this is 81 over 4. And that is the value that we need to add to both sides. When you are working with these calculations, use your calculator. So just let your calculator do the math for you. 32 plus 81/4. Can you even see that? I get a decimal, but if I, on my graphing calculator, if I hit the math button, and then the first option is to a fraction, hit enter twice, that gives me 209 over 4. So, depending on the calculator you have, it should give you somehow 209 over 4. So 32 plus 81/4, that's 209 over 4. So my condensed equation, I have x minus 9/2 quantity squared equals 209 over 4. Let me get that out of the way. So that's what my equation looks like. And now I can take the square root of both sides to solve. So square root, ignore that. So I have x minus 9/2 equals, anytime you take the square root, remember you need the plus or minus. And when you're taking the square root of a fraction, that's the same thing as the square root of 209 divided by the square root of 4. So that's plus or minus the square root of 209 all over the square root of 4, or 2. If I could simplify the square root of 209, I would. Because 209 is not divisible by a perfect square, I know that it will not simplify. So my solutions are, adding 9/2 to both sides, I get 9/2 plus or minus the square root of 209 over 2. Okay, or you can also write that as a single fraction, 9 plus or minus the square root of 209 all over 2, since both of these have a 2 in the denominator. And again, that is two separate solutions. One is 9 plus the square root of 209 all over 2, and the other is 9 minus the square root of 209 all over 2. Okay? Last example. When you are trying to solve a quadratic equation and you're wanting to complete the square, it needs to be that the lead coefficient is 1. So in this case, lead coefficient is the number in front of the highest degree term. So here, my lead coefficient is 5. So to make that lead coefficient, I need to divide by 5. But my multiplication property of equality says I can divide by, I said divide, right? I can divide by 5 as long as I divide both sides by 5. And both sides divided by 5 is the same as dividing each term. So I end up with 5 divided by 5. 5x squared divided by 5 is just x squared, plus 20 divided by 5 is 4, so that's 4x, plus 200 divided by 5 is 40, and that equals 0. Now looking at this equation, the directions do just say solve. I can look at this and see it's not factorable, but I do want us to solve using the completing the square method anyway. So to complete the square, I have to subtract the 40. So I have x squared plus 4x plus something equals negative 40 plus something. Okay, so I'm going to try to figure out what I need to put in the blank so that on the left-hand side I have a perfect square. Okay, and I want it to be a perfect square so that when I factor it into two binomials that are the same. And if these are the same, then I can write it as something squared. Okay, so first times first has to be x squared, so x and x. This guy times this guy has to be the last, and my inner and my outer have to add to 4x. Okay, therefore these both need to be plus 2. Right? These have to be the same in order to write it as something squared. So what we have on the left-hand side is x plus 2 quantity squared if the number that we put here is 4. So based on the factorization, we can see that 4 is the number that completes the square. So negative 40 plus 4, I get negative 36 on the right-hand side. Now that I have something squared equals a number, I can take the square root of both sides to solve. So square root, I have x plus 2 equals plus or minus the square root of negative 36 is 6i. Then subtracting my 2 to get x by itself, I have x equals negative 2 plus or minus 6i. So this quadratic equation actually has two complex solutions, non-real complex solution. So when you are trying to solve by completing the square, the big idea is that you have to make a perfect square on one side and you want it to equal some number on the other. Once you've done that, you'll be able to solve by extracting the root. Okay? You can determine what you need to add to both sides based on just the factorization like we were doing. We figured out the number that completed the square by looking at what the two binomials must be. And so once you have your equation in the form of something squared equals a number, then you go ahead and solve by extracting the root. So solve by completing the square really isn't a new solving method because you're still using the solve by extracting the root. What it is, it's just a way that you can manipulate your equation to get it into the form so you can solve using a